Hi, Simone. Welcome to Borealis.
Hi.
Really happy to have you here today.
Thank you.
Really great, exciting chance to show you a little bit about what we do as a polyolefins company. So Borealis makes polyethylene, polypropylene, and what we'll do today, coming through our facilities and our innovation headquarters here in Linz, is we're going to talk about how we go from polyolefin, like polypropylene, to pellets like this.
Then our customer converted into film, like that. And this film serves as a part of the laminate structure, that is it, which serves as a packaging for this nice lithium-ion battery pouch. So basically, if you can imagine, it's sealed like that. Therefore, the sealing properties, mechanical properties, and some other properties are super important for this kind of application. And I think we will guide you through the old testing lab to explain a little bit.
So let's get started and have a tour around the facility to show you what we can do.
All right.
All right, so Borealis is a provider of innovative solutions on polyethylene and polypropylene. For a lot of people, they might not know where this is coming from. When we get it out of the plant, this is how our product looks. This looks like polymer powder. Not very useful for us to use. This is not what we're actually selling as a material. Polymer powders need to be enhanced, and you can do that in a variety of different methods, one of which is through compounding. And compounding itself, basically what we're doing is we're taking our polymer powder, and we maybe want to improve the properties of that powder. We can incorporate different types of materials like glass fiber. Maybe we want different colors or additives, stabilizers. We can use elastomers. This is more rubber components here, or talcum. And in the end of that, once you have all of your ingredients in place, you're putting it through what's called a compounding line. And very much like it is when you're baking, you can have the best ingredients in place, but it's also dependent on the type of mixing machine that you have. And that's where this compounding step is so important. So by taking all of our ingredients together, we move to the technology itself, a compounding line. And that's made up of two what are called twin screw. This is a twin screw extruder. This is basically just a mixing machine. It could be specially designed depending on the types of components that you're putting in your compound. All this is fed in, it's all mixed together, and at the end you end up with these polymer granulates. And that can be used in a variety of different applications, one of which here being automotive bumpers that we could talk about, or in related to at least the battery space, we're using this to produce flame retardant compounds for our battery housings. And so maybe, Julia, you can talk a little bit about what makes this facility so unique at pilot compounding.
Yes, what is really exciting here is that we can test very quickly. We can change between different recipes to test a new recipe and even to do a scale up to real world production. What is also unique in our compounding is that we're combining our expertise in polymer science together with hands-on engineering to ensure that every batch of material we are producing is compliant with the highest standard of performance, safety and sustainability.
Great. So I would suggest maybe we walk through the facility to see one of these compounding lines in action. Servus, hello, Nina, hi. After we talked about compounding and what do we do with the polymers then, basically our facilities here in Linz, it's an innovation center. So we try as much as possible to imitate the processes that our customers have. One of those processes that's quite important for what we're doing is called injection molding. And here we can basically take different polymers, they will get melted, they will get put into an injection mold and we'll get different shapes out of them. They primarily focus on producing standard test specimens here for testing to look at different mechanical properties or different types of optical properties. And from there, then with those test specimens, we can go to our customers and say, hey, this is the type of performance we have with our materials. to determine what kind of mechanical properties they have, what the stiffness is, what the impact is, or even if something is transparent. So this one's here for stiffness. This one here could be used for impact, and these plates can be used for other testing purposes. So at Borealis, we try to mimic as much as possible what our customers would have in their own production. So when they're making different types of materials, different types of parts, pipes, and in this case here, in particular about film. So maybe Yulia, you can talk a bit about that.
So now we are here at cast polypropylene film line. This is it is not commercial line. It's rather our internal facility, which allow us to convert our own pellets into films and then rigorously test them before we can actually suggest a solution to our customers, who is real film producers. What is really exciting here that currently we are doing cast polypropylene film for lithium-ion pouch battery cell. And for this demanding application, we have combined 3 different types of polypropylene, each one selected by its unique properties, such as high seal strength, good deep drawability, and reliable adhesion. By using our cast process, we are combining these unique properties into a single high-performance film, which is lightweight, flexible, and secure. Exactly what is needed to protect lithium-ion pouch cell. Hi guys.
Hello.
So there are basically 2 ways that you can make film when you're extruding a film, and you could very much think about it like pasta. And so in this case here, cast film production, we have 2 dies that are pressed together and the film comes out as one film. And you can see it here, these coming out onto what's called this chill roller, which is immediately starting to cool it. So this glossy material here, that's the film. And this type of film technology, cast film production, is primarily used for polypropylene. And so the film comes through here, see it coming out, it's getting cooled on this giant chill roller, and then you can see it being extruded here. This is just one film being pressed out. And this is exactly how it would look, at least for the types of film that we're producing for our lithium-ion battery pouches.
A specific experiment, our cast polypropylene film is mounted in a tensile machine and then pulled with a constant speed. In such a way, we are measuring such important film characteristics like tensile strength, elongation, and resistance to tearing. Those properties are highly important during pouch fabrication, because during pouch assembly, material always undergo during this kind of stresses. Mm-hmm. So now we are standing at a sealing test station where we actually test our cast polypropylene film. The goal of this test is to develop a strong, reliable seal that would guarantee the withstanding of our battery.
We also benchmark our sealing results against the existing conventional method to get the full pictures. Okay, now we are at our test station for the mechanical strength. One of the most important properties for the mobility and the pouch cell is the puncture test. Here we use the standard probe to apply the force to molded plates from our material, same as like normally our customers do in the mobility and the pouch cell. And the purpose of this test is to measure how much energy the material can absorb before it fails. And this is very essential for the safety. imagine and the accident or impact, the material for the packaging should be resist to the puncture to protect the cell inside, packed inside. And yeah, we normally test the material at different conditions, like different temperature, different speed, different thickness. In that way, we can really simulate the real world to give a format to our customer to ensure that our material is robust and consistent at all application conditions. Also, as a material scientist, based on these learnings, like how the material behave under stress, we could fine-tune the composition of our material, and we also could play with the conversion technology and condition to deliver the best performance to our customers. So this is a typical results of our material. As you can see, before the material get break, we can absorb a lot of energy. This can help us to prevent catastrophic conditions like and the accident. We still can keep the battery cell under safe conditions.
After completing the sealing test, we are analyzing the seal with the help of optical microscope. What we are actually doing here, we are looking for any kind of tiny imperfection that might be present in the seal cross-section. Like in this example, you can see incomplete fusion. This is typically defect that we don't want to have in our pouch cell laminate. As you may imagine, the property of final pouch cell are determined by the quality of the seal. Therefore, we design our material to provide the highest seal strength possible.
All right, thanks for coming to our Innovation Center. We had a really good chance here to see all the different facilities, how we process polypropylene pellets, turn them into films, which can then be used in lithium-ion battery pouches.
Yes, it was nice to have you here, Simon.